In 1999, a man named Gary Halverson bought a Kenworth T800 with a Caterpillar 3406E engine. He has commented on our previous investigations to tell us that truck is still working today. 25 years later, it has crossed 3 million miles. The engine has been rebuilt once. Everything else is original. Now compare that to the experience of an owner-operator today. You walk into a Peterbilt dealership and you spend $160,000 on a brand new truck with a digital dashboard and an emissions system so complex it requires its own computer to monitor. That truck will spend its first 500,000 miles generating between $15,000 and $30,000 in repair bills on systems that have nothing to do with moving freight. And when it breaks down, it will not break down on your terms. The truck will decide when it stops. A computer will slow you to 5 miles an hour, whether you are on a highway, on a mountain grade, or in the middle of a blizzard. The repairman will not fix the problem on the road. He will tell you to wait for a tow. Why have we moved from an era of 3 million mile engines to an era of trucks that strand their drivers on the shoulder? In this investigation, we are going to expose the DPF scam, the EGR cooler catastrophe, and the DEF kill switch that turned the American semi-truck into a rolling emissions laboratory. The first villain on our list is the diesel particulate filter. For decades, a diesel engine did one thing with its exhaust. It sent it out the stack. The exhaust was dirty by today's standards, but the engine underneath was virtually indestructible. A Caterpillar 3406E or a Detroit Series 60 from the 1990s was built to run 1 million miles between major overhauls. The engineering was mechanical and straightforward. When something broke, a technician fixed it with hand tools. The truck went back to work. Then, in 2007, the EPA mandated a 90% reduction in particulate matter from every new heavy-duty diesel engine sold in the United States. Manufacturers complied. Their solution was the diesel particulate filter, or DPF. A DPF is a ceramic honeycomb filter bolted into the exhaust stream. It physically traps soot particles before they exit the stack. On paper, it works. In practice, it introduced a failure mode that did not exist before. A DPF collects soot with every mile driven. Eventually, it fills up. To clear it, the system must perform a regeneration. It injects additional fuel into the exhaust stream to raise the temperature high enough to burn the trapped soot away. That process requires temperatures above 1,000 degrees Fahrenheit inside the exhaust system. It subjects the filter, the surrounding exhaust components, and the downstream sensors to extreme thermal stress with every cycle. The filter cracks. The sensors fail. The differential pressure sensors that monitor filter loading give false readings and trigger regenerations that are not needed, or they fail to trigger regenerations that are needed. When a DPF enters a fault condition, the engine management system initiates a derate. The truck does not ask for your permission. It reduces engine power automatically to force the driver to stop and address the problem. A full derate limits the truck to speeds that are insufficient for highway travel. According to fleet maintenance data, DPF and after-treatment system failures account for approximately 40% of unplanned downtime in fleets after 2010. The filter itself costs between $3,000 and $7,000 to replace when it cannot be cleaned or regenerated back to specification. Active regeneration requires the truck to sit stationary for up to 45 minutes. For an owner-operator running a tight delivery schedule, that is not a maintenance interval. That is a revenue loss event. The old exhaust system had no serviceable components. It could not fail. The new exhaust system is a precision emissions reactor that costs thousands of dollars to service and can immobilize an 80,000-pound truck on a highway grade at any moment the computer decides. But even if your DPF survives, there is another system designed to destroy your engine from the inside. The diesel particulate filter attacks your wallet from the outside. The exhaust gas recirculation system attacks your engine from within. To understand why, you need to understand what it does. In a clean diesel engine, combustion happens at high temperatures, and high temperatures produce NOx, nitrogen oxide compounds that contribute to smog. The EPA wanted NOx reduced. The manufacturer's solution was to take a portion of the hot exhaust gas leaving the engine and route it back into the intake manifold, mixing it with fresh air before combustion. This lowers the peak combustion temperature and reduces NOx production. The component that manages this process is the EGR cooler, a heat exchanger that must absorb the thermal energy of recirculated exhaust gas continuously, under load, for the life of the engine. That is what it does in theory. Here's what it does in practice. The EGR cooler is subjected to extreme temperature cycling every time the engine loads and unloads. The internal passages that carry coolant develop microscopic cracks over time. When those cracks open, coolant enters the exhaust gas passage. That coolant is then carried into the intake manifold and into the engine. Coolant mixing with engine oil produces an emulsified sludge that destroys bearing surfaces throughout the engine. A failed EGR cooler is the mechanical equivalent of a stroke. The repair cost for the cooler alone runs between $1,500 and $4,000. If the contamination has reached the engine internals, you are looking at $15,000 to $50,000 for a rebuild or replacement. The most documented case of this failure is the Navistar MaxxForce engine. Navistar decided to meet the 2010 EPA standards using an advanced EGR system rather than adopting diesel exhaust fluid and selective catalytic reduction technology like its competitors. The company sold MaxxForce 11 and MaxxForce 13 engines in trucks from 2008 through 2012, while internal and field data showed the advanced EGR system was failing systematically. Class action lawsuits were filed against Navistar, alleging the company knew the engines were defective and sold them anyway. The EPA assessed $7.5 million in civil penalties against Navistar in 2012 for selling engines that did not comply with emissions standards. Navistar ultimately abandoned the advanced EGR approach entirely, switched to selective catalytic reduction technology, and paid out settlements involving hundreds of millions of dollars in repair reimbursements. Tens of thousands of trucks had already been sold in the interim. This is not an isolated engineering miscalculation. Cummins and Detroit have both issued service bulletins addressing EGR cooler failure patterns in their own post-emissions engines. The problem is not unique to Navistar. It is inherent to the design. You are routing the hottest gas in the engine through a heat exchanger that is asked to survive 1,000,000 miles. That cooler will fail. The only questions are when, and how much it costs you when it does. And then there is the system that gives the federal government a kill switch inside your truck. The DPF, the diesel particulate filter, is a filter that clogs. The EGR cooler, the exhaust gas recirculation cooler, is a component that cracks. Both of those failures are mechanical. They wear out under load, and a skilled technician can replace them. The DF system is different. The DF system can stop your truck before any physical component has failed at all. DEF stands for diesel exhaust fluid. It is a solution of urea and deionized water that is injected into the exhaust stream downstream of the engine. Inside the SCR catalyst, the selective catalytic reduction system, the urea reacts with nitrogen oxides in the exhaust to produce nitrogen and water, and is chemically effective. It is also a system with more than a dozen sensors, a dedicated pump, a doser injector, a heated storage tank, and a catalyst that must survive hundreds of thousands of miles of continuous chemical exposure. The system requires that DEF be stored on the truck in a separate tank. DEF freezes at 12 degrees Fahrenheit. In cold climates, the tank and all associated lines must be electrically heated to prevent the fluid from solidifying and cracking the components. When the heating system fails, the DEF freezes. When the DEF quality sensor fails, the vehicle computer reads the fluid as contaminated even when it is not. When the doser injector fouls at high mileage, the SCR catalyst does not receive the correct fluid dose. Any of these conditions triggers a D rate. A doser injector replacement costs between $800 and $2,000. If contaminated DEF reaches the SCR catalyst, the catalyst itself must be replaced at a cost of $5,000 to $15,000. The EPA mandates that a truck with a malfunctioning aftertreatment system enter progressive D rate until it is repaired. The Owner-Operator Independent Drivers Association, known by the initials OOIDA, has filed formal regulatory comments with the EPA documenting cases in which D-rate events have stranded trucks on highway shoulders, on mountain grades, and in extreme weather conditions, creating roadside safety emergencies. The EPA designed a system that punishes emissions non-compliance by making a loaded semi-truck dangerous to operate. The truck does not break down. It is shut down. There is a meaningful difference, according to OOIDA research. After-treatment-related costs add between 5 and 12 cents per mile to the operating costs of a post-2010 truck. At 100,000 miles per year, that is $5,000 to $12,000 annually in costs that have nothing to do with moving freight. Over 500,000 miles, independent owner-operators document between $15,000 and $30,000 in after-treatment repairs. The fuel savings from a modern engine, roughly 5 to 8% better efficiency, do not close that gap. So what did the smart money do? They found the loophole. Before the emissions era, Caterpillar built what many working truckers consider the greatest diesel engine ever produced for on-highway use. The 3406E and its successor, the C15, were known for one thing above all others: durability. They ran forever. Owner-operators built entire careers around those engines. Fleet managers specified them by name. The engineering was robust, the parts were available everywhere, and a competent shop could overhaul one on the floor of any decent diesel facility in the country. A well-maintained Cat truck engine could reach 1 million miles between major overhauls. Some exceeded that significantly. In 2009, Caterpillar announced it would not produce an on-highway diesel engine meeting the 2010 EPA emissions standards. The company concluded that engineering its truck engines to carry diesel particulate filters, selective catalytic reduction, diesel exhaust fluid, and exhaust gas recirculation systems was not commercially viable for its product line. Caterpillar did not cut corners. Caterpillar walked away. The last Cat truck engine rolled off the production line in 2010. There will not be another one. What the trucking industry lost was not a brand name. It was an engineering standard. The 3406E was designed in an era when the only performance metrics that mattered were power output, fuel efficiency, and longevity. The engineers optimized for durability because that was what their customers paid for. The EPA mandate added a new performance metric, exhaust cleanliness, and the cost of meeting that metric, integrated into an engine designed for 1 million miles, was not a problem Caterpillar was willing to solve by compromising the engine. The market has responded in a way that makes the loss explicit. Trucks built before 2007, equipped with the Caterpillar 3406E or C15 engines, currently sell for $40,000 to $80,000, prices comparable to newer trucks with full emissions systems. The premium is not nostalgia, it is economic calculation. A trucker paying $60,000 for a 20-year-old truck with a mechanically simple engine is making a documented bet that the absence of $15,000 to $30,000 in after-treatment repairs over the next 500,000 miles makes that purchase the better financial decision. On the forums where working owner-operators discuss equipment, the consensus among high-mileage operators is consistent. The pre-emissions truck has lower total operating cost for owner-operators running older equipment without fleet service contracts. This is not a theory. This is the market pricing the value of an engine that was legislated out of existence. If you are an owner-operator, or you are thinking about becoming one, here is what the smart money is doing. They are buying pre-emissions trucks, specifically trucks manufactured before 2007 when the Environmental Protection Agency standards took effect, and they are looking for engines by name. The Caterpillar 3406E, the C15, the Cummins N14, and the Detroit Diesel Series 60 are the engines worth finding. These are not antiques. They are mechanically straightforward diesel engines that have been running in commercial service for decades, with parts availability and a repair network that understands them completely. When they break, a technician fixes them. There is no aftertreatment system to derate you, no diesel exhaust fluid tank to freeze, no diesel particulate filter to crack at highway temperature. The truck runs or it does not, and if it does not, the reason is mechanical and fixable. When you shop for a truck, reject the touchscreen, reject the emissions warranty, reject the dealer's assurance that the aftertreatment system is covered for the first 100,000 miles. Do the math on what comes after that coverage ends. A $160,000 new truck generating $12,000 a year in aftertreatment costs is not a productivity tool. It is a payment plan for a rolling emissions laboratory. Keep the old iron running, maintain it, rebuild it if you have to. The engine that was built to last 1,000,000 miles is still worth 1,000,000 miles, and it will not strand you on a mountain grade because a urea sensor gave a false reading at 2 a.m. in January. They designed a system that puts a federal kill switch in your cab. Stop buying their emissions experiment.